Christmas morning 2021, NASA just launched a $10 billion telescope folded up like origami, headed 1,000,000 miles from Earth. Nobody's ever going out there to fix it. Not an astronaut, not a robot, nobody. And over the next month, that telescope has to unfold itself, alone, through 344 separate moves. Engineers had a cold little name for each one, a single point failure, meaning if this one thing breaks, that's it. Mission over, no plan B. 344 of those, and it only takes one. Here's why they even built it this way. Webb was meant to replace Hubble, except it had to see something Hubble never could. Infrared light, the kind that slips through clouds of cosmic dust that block everything else. That's what lets it catch the faint glow of galaxies that formed right after the Big Bang, light that's been traveling toward us for over 13 billion years. But to see that far back, the telescope has to be brutally cold. A few of its instruments needed to sit at around 7 degrees above absolute zero, so it needed a sun shield the size of a tennis court just to hide from the heat of the sun, the Earth, even the moon. Problem is, a tennis court doesn't fit inside a rocket, neither does a mirror 6.5 meters wide. So NASA folded the whole thing up. The mirror hinged in on itself, the sun shield packed down into 5 layers of a material thinner than a human hair, wrapped so tight it looked like a piece of intricate paper craft. Which meant once it launched, every one of those folds had to open back up, perfectly. By itself, 1,000,000 miles out. That distance matters more than people realize. Hubble sits close enough that astronauts flew up and fixed it 5 separate times over the years. Webb was never going anywhere astronauts could reach. It was headed to a spot called L2, gravitationally calm, ideal for a telescope, and completely, permanently out of anyone's hands. So the sun shield became the whole ball game. 140 release mechanisms, 70 hinges, 8 motors, about 400 pulleys, a 1/4 mile of cable. All of it had to fire in the right order, tensioning 5 paper-thin layers without a single snag or tear. And here's the part that kept engineers up at night. They couldn't really test this on the ground. Gravity gets in the way. Cables and membranes just don't move the same way on Earth as they do floating free in space. All the simulations, all the years of testing, none of it could tell them for certain it would actually work out there for real. 3 days after launch, the unfolding began. A tower extended, lifting the mirror clear of the spacecraft body. Then the sun shield's covers peeled back. Then the booms stretched out, pulling 5 stacked layers into their final kite shape. Tensioning, the scary part. Pulling each layer taut one at a time. Engineers even paused the whole sequence for an extra day, just to double-check the power systems before pushing forward. Layer by layer, it held. On January 4th, 10 days after launch, the 5th and final layer locked into place. That one moment alone had just cleared out nearly 3/4 of all 344 failure points. NASA's own administrator later said that even though he trusted the team completely, he was still nervous the whole time because the rocket had done its part perfectly, and now it was all down to this. A few days later, the mirror wings folded open, 18 gold hexagons locked into a single, seamless surface. By January 8th, the telescope that once fit, folded inside a rocket, had turned into something the size of a small building, drifting quietly toward its final home. NASA had a nickname for that whole stretch: 29 days on the edge. Every single one of those 344 things had to go right, and they did. Today, Webb runs on about a kilowatt of power, less than some household kettles, quietly pulling in light that left its source before Earth even had oceans. It exists because for 29 days, hundreds of parts worked exactly right. The first time they were ever really tried, a million miles from anyone who could help.